Thank you. So my name is Axelle. I work for Fortinet, and I work mainly on Android malware and connected objects. And today it's going to be mostly on connected objects. I'm also the lead organizer of a phone CTF, which is a CTF in the south of France, and which is dedicated to connected objects. And last but not least, I'll be talking to you today about a smart coffee maker machine. I don't drink coffee. So during all my research, my colleagues had to drink the coffee I was brewing for that. So thanks to them. So those are the two devices we are going to discuss today. You've got on the left-hand side the coffee machine, which is connected. Both devices are Bluetooth low-energy devices connected that way. And on the other side, you've got the jump rope. We'll be discussing both. Both have been integrated in challenges for phone. The coffee machine, it was in 2019. And the jump rope, it was in 2022, in December, 2022. So let's start with the coffee machine. Well, actually, it's really interesting because, well, I'll discuss actually that a little bit later, but you can hack in three different points. You can hack on the hardware, in the communication, and on the smartphone. Okay? So, let's start a little bit, but with hardware reconnaissance. In there, I open the coffee machine, and this is what you see. You see the buttons on the top, okay? And this is the back of it, with something also all the mechanisms which control the flow of the coffee. And if you go beneath the buttons, well, you've got a PCB, and if you have a look at what is written on the top right, well, basically you get some numbers, and basically it says also, I think that it's waterproof, one part of it, and the other part is helpful to find it on the net. And you can find the separate part for it sold on eBay, which is pretty cool because it means that if your coffee machine has an issue, well, you can repair it. It's something like 35 euros, depending. So this one I think is from eBay in Italy. But yeah, it depends. I also saw one in Australia, I think. And the other thing that you see in eBay is that actually this PCB also works for lots of different coffee machines. So probably well, it's a supposition. I'm not entirely sure of that, but probably it was subcontracted to a company who then sold it to multiple coffee makers, different brands, and it works for all of these. If you have a look at the hardware components on there, well, you see an STM chip, which is an 8-bit microcontroller. And more interesting to me, the other chip there is the BLE chip. So actually, if you've got good eyes, you can see on the stamp on it that you've got the FCC ID. You can go to the fcc.io website and look for that, and you get all the details, exactly what chip this is, and all the specs which are there. So this is pretty interesting. And then the other thing which is really interesting when you're trying to hack a device, I think, is to have a look at the documentation. That is, if you are lucky enough to have some documentation. And for the smart coffee machine, there is very good documentation there. And in the instruction manual, in particular, you can see the reset to factory settings. Now, this is really, really important to have as an information when you're trying to hack something. I had to, of course, use it several times. So this is really interesting information, for instance. More information this time in the service manual. This is awesome. I wish that all manufacturers were providing such good documentation, honestly. Look at this. I mean, this is wonderful. You've got everything you need to repair it. Besides my work, I'm actually working at a repair cafe down in Nice in the south of France. And if I had all this documentation for all the things I'm trying to repair, it would be really great. And okay, this is good. So what have we learned? Well, we've learned that the coffee machine has a BLE chip. It's not a great deal. We already knew that, okay? But, well, okay. We know that the PCB is used for many different coffee machines, probably. We know how to reset to factory settings, so this is going to prove out to be very useful. And we know probably, or at least better, how to repair the coffee machine, and this is really awesome. If you are more skilled than I am in hardware, if you have, for instance, corresponding to the previous talk of Thomas, well, if you have his skills in hardware, you can probably dig in much more on the hardware part and find many more things. Those are not my skills, okay? So if you are like me, like I am, not skilled in that part, well, you have more than your eyes to cry. You can do something else still. Well, you can hack, for instance, in the BLE communication. So there, we can try and sniff the Bluetooth communication. There are basically two different tools that I know of. Both are really old. It's Ubertooth and Adafruit LE Sniffer. I think that Ubertooth was presented, I think, in 2011, so it's pretty old, more than 10 years old, but it's still maintained, and you can use it, like the other one, to sniff the Bluetooth communication. It works very well, and you get all the packets, which is a little bit more than we really need, because in this particular case, we are only interested in one specific layer of Bluetooth, which is the AT protocol. The other issue is that I'm not actually that much at ease with those sniffers. I know how to use them, but I tend to forget all the time how I have to set them up again. It's a little bit complicated. You've got to flash the firmware, then you've got to patch your Wireshark, then, all that stuff. It's doable, but I probably don't do it often enough to be really at ease with it. So, first two parts, well, it's not the easiest in my humble opinion, or not for me, at least. Of course, it's the last one. Okay, I'm going to do everything from the smartphone. And you're going to see that actually we can find lots of information from the smartphone, and it proves out sometimes to be extremely easy and handy to use that way. So, one of the first things you have to do when you are dealing with a BLE device is to list all the services and characteristics of the device. That's the way BLE is organized. We're not going to get into the specifics, but basically you've got services, and in there you've got characteristics, which are kind of entry points you can read or write to. If you want to list that, you've got smartphone applications like NRF Connect. You've got others. But they give a very good results there. If you want to do it from your laptop, it also is possible. For instance, I'd recommend like a CAD tool. Well, it's deprecated. It's been deprecated for years, but I know that some of us are still using it very much because it's simple to use and very convenient. Its replacement is actually Bluetooth control, which is also excellent as well. Perhaps a little bit more verbose. It's a bit too talkative, let's say. Okay, but it works. So you can get the lists of exactly this, which is all the services that you have on your device. So on the smart coffee machine, you've got standard services, generic access, generic attribute, and then all the other ones are specific to the coffee machine. And here in this case, we can see that the developers really kind of organized the various characteristics in a thoughtful way. Like, you've got the errors at some point, things that users can customize in another, and things like that. We're going to discuss those a little bit more afterwards. So, one of the first things you have to do when you are dealing with a BLE device is to list all the services and characteristics of the device. So on the smart coffee machine, you've got standard services, generic access, generic attribute, and then all the other ones are specific to the coffee machine. And here in this case, we can see that the developers really kind of organized the various characteristics in a thoughtful way. Like, you've got the errors at some point, things that users can customize in another, and things like that. We're going to discuss those a little bit more afterwards. Then, what we want to do, of course, obviously, is to connect to the coffee machine. First thing that happens, you try to connect, and it spits out an error telling you, well, it requires authentication before read and write. So there, you can go and have a look at how security modes are defined in BLE, and you'll see there is level 1, 2, and 3. Basically, what you need is level 3, which is authenticated encryption, and which is actually pairing. Okay, it's kind of the same. So if you want to get this, well, you use get tool. Get tool, you've got to say that security level here is high, because that's what means actually level 3. Moderate, I think, is 2, and low is 1, something like that. And if you're using Bluetooth control, it's, I think, a little bit more intuitive there, because, well, you just say that you want to pair to a given device, and you get the pairing. Then you try again to connect. And you think it's going to work, and no, not exactly. It tells you this time attribute requires authorization before read-write. So the first time I got the error, I read too quickly. I thought it was authentication, and I thought, damn, my pairing didn't work. It did. It's not that. It's different. Authentication, authorization, totally different. Okay. Now, this is really rare in BLE devices. It was the first coffee machine, well, smart coffee machine, first BLE device actually in the end that I saw with authorization at all. Okay, so it was particularly interesting to me to deal with that because I hadn't ever seen that. It's totally implemented by the device itself. This is not part of, well, the Bluetooth specs say that it's up to the device to implement the authorization the way they want. Sorry for this. I'm going to move it a little bit. Yeah. So how do I get authorized? So this is where I'm going to sniff the communication, but I'm not going to sniff using Bluetooth or something else. I'm going to sniff directly on the smartphone. If you've got a rooted device, well, you can actually on Android pretty easily enable Bluetooth snooping. It's really not difficult to do. It's like you click on various menus and it works. And then you get the PCAP on the smartphone directly. You transfer that and you put it in Wireshark and, well, I'm happy. Okay. And you get that. So, well, maybe at the back you can't exactly read, but those are just a list of enumeration packets in there. So it's kind of enumerating all the services and all the characteristics. Okay. Then you get a read request on handle 16. Okay. Then you get a write request on handle 14. Now, if you want to get authorized, obviously you're going to have to write something, okay? So I thought, okay, one way or another, the write request is going to be really interesting to me because possibly this is what is going to give the authorization code and prove that I am somebody to be trusted, okay? Or that I am this authorized person. And indeed, it is that. So in the packet, in here, we have the authorization code to be sent to the smart coffee machine. Okay. Now it's useless just to take a screenshot of that one because it is changing every time we are repairing to the device. So you've got to get this code by yourselves by doing by sniffing the communication. Then you get it, and then you are authorized for the rest of the possibly long session. And by the way, normally we'll have the smart coffee machine at Fortinet's booth today. So if you want to try and hack and get your coffee that way, well, you can. You're welcome to try and hack the machine. Then in phone, what happened is that one of the challenges was that we wanted the hackers to get a 90 milliliter cup. Okay, normally Ristretto is 25 milliliters, Espresso is 40 milliliters. You see, I've learned quite a lot about coffee now. Okay, and Lungo is 110 milliliters. Okay. So you can cheat, but you're not supposed to. You can do 2 ristrettos and 1 espresso. That will be also 90 milliliters, but you were supposed to get that in 1 cup, not in 3 cups. Okay? So we're going to try and do this. So here we go in the code of the Android application, which is supposed to control the coffee machine. And we see a class which is named cup size volume, and this looks like, you know, a good place to look into. And you see the different ranges which are acceptable for ristretto, espresso, and lungo. So if we want 90 milliliters, well, it works for lungo. It won't work for ristretto and espresso because it's not beyond the range. Okay, cool. And now, how are we going to do to set this? Well, we have a look at another class which is called cup size operations. The name isn't obfuscated in the code, so this is handy. And you see that there's a service. The service is user options, and then you've got 2 different characteristics: cup size and cup volume. So what we'll have to do is to specify we want to hack lungo, cup size, and cup volume, or 90 milliliters. Now, a small note there is that it's handy to work on handles, okay? But sometimes you have only the universal identifier, which is there. So if you want to make the matching and know what is the handle, well, actually Bluetooth control gives you both. This is the UUID, and this is the handle in here, and this is the address of the MAC address. So it's an easy way if you want to work with either. Well, you have both information, which is cool. So cup size. So it's a specific protocol, well, a specific packet format. So but it's really extremely easy. It's only 2 bytes, and for lungo, well, you just have to specify number 2. And it will customize lungo. Cool. Cup volume, it's slightly more complicated, but still not very complicated. It's 4 bytes. Actually, the two first ones is the volume in milliliters, and the last 2 are fixed, always FF. Okay, so we know. I'll come back. Yips. We know how to specify the cup that we want to customize, and we know how to specify the number of milliliters. Now we've got to be able also to tell the coffee machine, okay, do me my coffee, okay? And here I'm skipping a little bit of parts because, well, we don't have like a 2-hour session, but in the code, you see again that there's another command with a specific header, okay, which basically would tell the coffee machine to brew a coffee. And then you specify the delay. When do you want your coffee? Do you want it tomorrow morning, or do you want it just now? And what type of coffee you want? Well, what type of cup? So here, for instance, if we want our 90 milliliters cup of coffee, we'll say that we want it now, so the delay will be null. And the coffee type is going to be lungo, so it's going to be 0002. And you send this command, well, to this given service, which is here, and the characteristics to send it to are written there. So it's the brew key in here, handle 24. Now, just a summary. So if we want to finally get our cup of coffee, we've got to pair, to authorize, to get, well, the authorization code, to customize say that we want to customize the lungo cup, customize the volume, 90 milliliters, and then tell it to brew the cup of coffee. And this is where I'm going to show you, well, actually a video, because I didn't dare to bring the coffee machine just here. So it's this one. So on the left-hand side, you've got the script, and on the other one, well, you've got the coffee machine. And you see that on the cup of coffee, I've marked Ristretto R, E for espresso, and the higher one is a lungo. And if I manage to get, if we get to the 90 milliliters, it's going to stop just below those, the lungo, which is 110. So this is normally 90 milliliters approximately. And by the way, that's what some participants had to do to flag the challenge. So that was cool that some of them did. So resuming, you can do actually more, but that wasn't part of the CTF. I mean, this coffee machine is amazing. I love it. You can do actually a recipe. So you can say, I want a little bit of water, this volume, then I want a little bit of coffee, then I want again a little bit of water, and you can build up your recipe. You can tell the temperature you want it, and then you can create a recipe for that, give it an ID, and it will do it just the way you like it. Because that's another thing I've learned from my colleagues, is that nobody likes the same coffee. Okay, so, okay. You can do much more, and this is where, if you want to play afterwards with the coffee machine, I suggest that you take a screenshot of this one, because you can do much more. You can get, for instance, the control. The coffee machine will tell you, for instance, if it's missing water. So you've got all the responses like that, and you can get that. You can also set up water hardness and say if it needs to be adjusted or not. There's even a BLE command if you want to do a factory reset. Okay, so plenty of other things that you can do. And if you feel like it, well, you have some more technical information in that document. One of the issues I thought is that also, well, this coffee machine is a bit strange, but the designer only thought that one person would connect to it, because you can only be it's only possible to pair one person at a given time. Which means that if, colleague A is paired, well, colleague B is going to have to unpair colleague A, pair again, and talk to the machine. I mean, this is never going to happen, and I'm sure you've all struggled with BLE pairing before. It's a nightmare. So really, this is not really very practical. So I thought, how can we make this available to all colleagues, okay, in a more efficient manner? Well, simple. You can just use a Raspberry Pi, and it will act as a BLE relay. Okay, so I connected it to the Bluetooth machine, and then I built, a basic web interface, which would my colleagues would go to and say remotely, I would like my coffee, I would like it here, etc., and things like that. And that's also something I've got a short demo for. I don't have, though, the happy face of my colleagues there to show. But there, well, this is my web interface. It's not very nice, but I'm not very good at design that way. And there you push a button and you get your coffee. And I even implemented the error feedback. So if coffee is missing, it's going to complain and tell them, well, yeah, okay, you want coffee, but there's no coffee. Okay. So that's the way it works. So, this is available also on GitHub. If ever you've got the same, or a matching, coffee machine, you can get it from here, and happily you will be able to get your coffee over Wi-Fi instead of BLE. We're done with the smart coffee machine. Now we're gonna do a little bit of fitness with a jump rope. It's basically the same because it's still a Bluetooth low energy device. Just the same, well, as you can imagine, you can hack it on the hardware part or on the communication part, but you already know that I'm going to do everything here from the smartphone. So actually, that's something that Thomas mentioned at some point in one of his slides, is that, do not forget to have a look at the system logs of Android, because you can find sometimes really valuable information. And here, it turns out that actually the application is logging everything that you want on the Android system logs, including Bluetooth packets. So I'm going to show that, and this is going to be a live demo. So enjoy. Hopefully I will enjoy it as much. It might not work, never know. So, screen copy. I'm going to show you my smartphone. So there we go. This is the smart. And now the logs and logcat. So it's logging everything with the tag, the section tag in there. Okay. So I can start this. I'm gonna connect the smart jump. Oh, yeah, it's working, right? Yeah, I understood. There we go. And it has disconnected. So this is Bluetooth. There we go. Okay, so this is all the logs that you get. I don't even need to jump, but I'll come and do it. Because you'll see, actually, that you get more logs. Yeah, sorry. So you get it here. So, actually, if you have a look at in the logs, well, we'll see some of them, but I'm looking for, by the way, this is, each time I was jumping, it tells you lots of things, so that was probably the 6th jump. And battery is 100%, looks like. Okay. Not sure of that, though. I'm looking for one specific log. Yeah, this one. Oops, where, this one. Here. This is exactly the raw packet which is sent, by Bluetooth. Okay. So this is pretty interesting, there, because it will help you afterwards understand how to deal with and communicate with the jump rope. So there you've got it. As you've seen, well, I don't know, maybe you speak fluent Chinese, but I don't. But my main difficulty was there, that you just have to translate it. But once you translate it, it's okay. It's really relatively clear. You've got, well, battery data here. The battery level in that case was 70. Here, this exactly translates to by, there is a buzzer, you'll see afterwards, but it has a buzzer and it can make a little bit of noise. So it helps very much to continue the reverse engineering because, well, you basically go in the code and you're gonna copy those Chinese characters to search them in the code. And for instance, well, here I end up in a method which is called update battery, and which was quite logical. It was saying something about battery level, so this is fine. And it tells me that, so probably BLE live data is a class I need to investigate. For the one with the Bluetooth raw packet, so I copied the characters in here, and it ends up in a method which is named parse command. This is also something that hackers will love whenever you see parse commands, stars in the eyes, things like that, okay? Blue LE service is another class which is probably interesting to look into. And, well, you look into that. It takes a little bit of time, but you will get the full picture, which is understand how to discuss with the jump rope. Basically, there are 3 different modes with this jump rope. the number countdown mode, which means that you are going to say, I want to jump, 500 times. The time countdown mode is, I want to jump 5 minutes. And then the free jump mode is, I don't know what I want to do, but just let me jump, okay? So this is the way to send this command to the jump rope. So in Phone 2022, what people had to do was to try and initiate a command where they would do 1,337 jumps. Okay, so what they had to do is to connect to the device. Then the organization of the jump rope in terms of services and characteristics, it's much simpler than the smart coffee machine. There's basically only 1 or 2 important services. And so you get easily the characteristics you can write to, because I think there's only 1 actually, so there's not lots of choices. And then you send the command that I said over here, which is, well, some basic thing at the beginning. Then you say, it's number countdown mode, so I'm going to specify a number of jumps. Then in hex 539, well, that is the target number of jumps I want. And the last 2 are a CRC, a checksum. So you just have to figure out that it's CRC 16 Modbus, but that's the only difficulty you have to do. Okay. And yeah, I've got another demo. Yeah. So we don't need a phone for this one. So I'm going to show you how I communicate with the jump rope directly. Okay. Well, looks my screen has frozen or what? Yeah. Yeah, it's not clicking. Just trying. Okay, so I'm rebooting. Sorry for this. So I'm going to show you afterwards a program which communicates by BLE to the jump rope, and we're going to send the commands there to start and jump and things like that. Okay, rebooting. Don't worry, it's normal that you're not seeing anything because, well, I unplugged the HDMI cable. Yeah, looks like this is fine. Well, unfortunately, I had set it up, and I'll have to do it again. But so we go in jump rope directory. And I'm going to try, I need also to show you my camera, okay? So, cheese. So what happens is that there's a small LCD screen on the jump rope, and that's what I want to show you. Yeah, not too bad. So, and I'll put this in there. Okay. So I'm connected. We're gonna do, how many jumps do you want? Okay, 800. It's not working. Okay, let's do it again. Okay, so I should put it the other way around so that you see that perhaps better. But you can normally approximately see that it says 800. Yeah, sorry for this. It's not really obvious. Now, I do not intend to do 800 jumps, so we're going to cancel that. Canceling it. Then you can try a time jump, and I'm going to jump for 400 seconds. And this is, you see exactly the number countdown there. Then, my colleagues were annoyed with the buzzer, so I had to do something about the buzzer. So this is buzzer off. And now let's try, the free jump mode. No, sorry, I've got to cancel first the other one. So canceled. When it canceled, it tells me I spent like 22 seconds doing nothing. Okay. And now I'm going to try free jump mode, and there it tells me, well, okay, go on, but you've done nothing. Okay. I can cancel that. And then because I liked noise, I'm going to put the buzzer back on. You've got the buzzer. Okay. Okay, so let's go back to the slides. Yeah, thanks. I'm happy nobody among the audience connected to the jump rope. So I'm going back to my slides and we'll finish up. Yeah, this is done. Now, this is not totally done for a CTF. Because how are we going to validate the flag? We want basically the participants to know how to send the correct command, but in return we've got to give them a flag, so how are we going to validate that? There are various options. One of those is, well, to do the manual validation. They show us that they are able to trigger the number of jumps, and we give them a flag in return. It always works. That's something we can always try. Oops. We have also the possibility to have a web server. Okay. And then people would enter on the web server that they know how to do the number of jumps. But it's missing kind of the BLE interaction, so I didn't really like that. The other thing was, well, we're gonna modify the firmware on the jump rope, and we will display the flag. But unfortunately, as you might have seen, it's really only a 4-digit LCD. So I don't think it's possible to display the flag in there. Okay, it would have been really difficult. So I ended up with the last solution, is that I would like to build a fake jump rope, which behaves exactly the same from a BLE point of view, but just has no rope. Okay. So I tried that. I tried that for weeks, perhaps even months. It was never working. There are plenty of different packages to deal with BLE. I don't think that maybe I was unlucky or else, but it was never working totally. Sometimes the packages were extremely old, so I even could not install them any longer. Some other times, well, it was working to some points, but then it was bugging. Then probably I added my own bugs also on top of it. So I was like, thinking that maybe I would abandon that. And then I went to another CTF I participated to, which is hardware.io. And they were featuring a very nice BLE challenge. And I'm not going to ruin their challenge, but I thought, yeah, that's exactly what I should be using. They had kind of a server, which was like a small Arduino-like board, and which was doing which was acting as the BLE peripheral. So I asked them for the code after the CTF. They shared, which was really cool of them. And I had a look, and I don't know why I hadn't thought about that, but it was really easy and straightforward. Just use the BLE from Arduino ESP32. So I bought 3 different ESP32 boards and started designing the fake jump rope. So I reused exactly the same services, the same characteristics as the real board, so that it really would look like the real one. Except that, for instance, on the jump rope, there is an over-the-air service for firmware update. Well, obviously, I have no idea how to implement that on the fake jump rope, and it's useless. So I just left it, but it wouldn't do anything on the fake one. And I added a specific CTF service, which was pretty much recognizable with a very strange UID, dead beef, in here, and only one characteristic with a flag. Okay. Now, if one of the team manages to know how to do the requested number of jumps, I don't want, they will get the flag, but I don't want the next team to come in and see the flag without having to do anything. Okay? So to prevent that, the solution is, of course, to erase the flag between all teams. And what we implemented was a solution where only one team would be able to connect at a given time. And when they were connecting or disconnecting, I would remove and erase the flag. It worked very well. We implemented 3 different fake BLE jump rope servers, just to make sure that, BLE is BLE. I'll talk a little bit about that. We sometimes have bad surprises, so it's always good to have 3 different items in case it is needed. So a little bit of advice and takeaways from different perspectives. Hackers, well, don't forget to inspect Android logs. From a developer point of view, I'm not saying that you should remove all logs, because some are just very useful, but if it's debug logs, then you should think about removing them. Normally, if you're in a company which is used to producing code, this is really standard, and there are procedures to make sure that the logs are removed. But here we're talking about connected objects, and I have the feeling that it's a poor intern who was affected to developing the stuff in overnight, and sometimes the development is a little bit crappy. BLE connection is always painful. That's, always the case. I haven't experienced too many issues with the smart coffee machine, except for pairing. But with the jump rope here, sometimes I get unwanted disconnections. I don't know why, but this probably means from a developer point of view that the quality of the BLE chip is not the same at both ends, okay? Or the way it is manufactured in the device is probably different. As much as possible, if you're a developer, I would recommend not to use pairing, because pairing, I managed to do it, but there's no way that my father would be able to do it. I mean, it's really complicated. Okay. BLE notifications is also something I haven't discussed, but it was really useful, especially for the smart coffee machine. Activate all notifications that you can. You will get much more messages, and it's helpful to see the status of what things are what is happening. BLE encryption, that's also another part. I have hacked quite a few of different BLE devices. None of them have ever used BLE encryption. It exists, but nobody uses it. So, well, if you want to communicate secrets, that's a way to do, at least. Manuals, well, yeah, they're really useful, especially to get the reset procedure. And you can also get some hints on the hardware. And from the developer's point of view, well, if you want to go green and you claim you want to go green, well, the really good thing to do is to give some opportunity to people to repair the device that you are giving them. Okay, so I don't know, give good manuals, service manuals. That is really good. Different parts, where to find and repair parts. If you can't, well, maybe 3D designs of the parts that you would like, that would be helpful to repair. That's good. Hacking. So how now? Let's suppose that you want to hack a new device. After this, where should you start? Well, it really depends what you are good at. If you master the hardware part, go and start from there. If you don't, and you rather are good at Android hacking and things like that, like me, well, it's obviously rather in the Android part that you should do some reverse engineering. The other thing also, which I think is interesting to point out for developers, is that hackers are not your enemies. Hackers are not attackers all the time. And especially in all the hacks that we've seen so far, well, they were all positive hacks. I mean, I'm not breaking anything, okay? I'm actually making the coffee machine more usable because it's now usable over the Wi-Fi, and I can get my famous 90 milliliter cup. Okay, it's maybe useless, but it's fun, okay? But yeah, it's useful, and we only hack things that we like, to be honest. Otherwise it's not, or that we find funny, otherwise we wouldn't be doing it. Now, this is a little bit more part of my job. I thought of, well, is it possible to infect either of these devices? Fortunately, in that case, it is not, because there is nothing where we can really substantially store a malware. It doesn't need lots of space. A malware, a few bytes or at least 1 kilobyte would be sufficient. But we don't even have that. They are really limited there, so this is good. But if you are designing a connected device which is connected to internet and has storage, even a little bit of storage, really pay attention to this, because they might get compromised and serve to compromise other hosts afterwards. So this you need really to pay attention to. And that's all. Thank you very much for your attention.
Okay, so do we have questions? We have a few minutes at the moment. Coffees are being prepared in the main room, and I think it's a good idea to keep you here, to not let you go to the coffee machines right there. So let's start there.
Wait for the microphone.
Disclose, I think on Nespresso, do you have disclose all process at Nespresso, and maybe they have some feedback or not?
I haven't sent it to Nespresso in that case because it wasn't a vulnerability, right? Okay, so I thought that they wouldn't really be interested. However, if they want, for instance, to implement on their app the possibility to customize the volume, well, they are more than capable to do it. So it would be possible. They can go and get it. I mean, it's public also for them, but yeah. So the answer is no, because I thought it was not a vulnerability.
Any other question?
Same for the jump rope, by the way. I didn't disclose because, well, it's just using it another way, but it's not really vulnerable.
Okay. Thank you, Axelle.
Welcome.